Hello, today we're going to learn programming fundamentals in software development. In Module 2, we have these topics: object-oriented programming concepts, data structures and algorithms, debugging and error handling. Object-oriented programming (OOP) is a programming paradigm that is based on the concept of objects. Objects are instances of classes, which are user-defined data types that encapsulate data and behavior. Here are some key concepts of object-oriented programming. 1. Encapsulation. Encapsulation is the practice of bundling data and behavior together in a class and hiding the implementation details from the user. This helps to protect the integrity of the data and make it easier to maintain the code. Abstraction. Abstraction is the process of defining a set of properties and methods that describe the behavior of an object without specifying the implementation details. This allows the user to interact with the object without needing to know how it works internally. 3. Inheritance. Inheritance is the ability of one class to inherit properties and methods from another class. This allows for code reuse and helps to create a hierarchy of classes that share common properties and behaviors. Polymorphism. Polymorphism is the ability of objects of different classes to be used interchangeably, as long as they share a common interface or set of behaviors. This allows for more flexible and modular code, as objects can be swapped in and out without requiring significant changes to the code. 5. Classes and objects. Classes are the blueprints for objects, defining their properties and behaviors. Objects are instances of classes that are created at runtime and can be used to interact with the program. 6. Methods and properties. Methods are functions that are defined within a class and can be called on objects of that class. Properties are variables that are defined within a class and are used to store data associated with objects of that class. OOP is widely used in modern software development, as it allows for modular and flexible code that can be easily maintained and extended over time. Data structures and algorithms are essential concepts in computer science and software development. Data structures are used to organize and store data on a program, while algorithms are used to manipulate and process that data in a specific way. Here are some key concepts of data structures and algorithms. 1. Arrays are a basic data structure that store a collection of elements of the same data type. They allow for fast access to individual elements, but may be less efficient for inserting or deleting elements. Linked lists. Linked lists are data structure that consists of a sequence of nodes, each containing data and a reference to the next node. They are useful for dynamic data structures that can be modified easily, but may be less efficient for random access to individual elements. 3. Trees. Trees are a hierarchical data structure that consists of nodes connected by edges. They are useful for representing hierarchical relationships, such as file systems or organization charts. 4. Graphs. Graphs are a data structure that consists of nodes and edges, which can be used to represent complex relationships between objects. They are used in a variety of applications, such as social networks and route planning. 5. Searching and sorting algorithms. Searching algorithms are used to find a specific element within a data structure, while sorting algorithms are used to arrange elements in a specific order. Common searching and sorting algorithms include linear search, binary search, bubble sort, and quicksort. 6. Complexity analysis. Complexity analysis is the process of analyzing the time and space complexity of an algorithm. Time complexity refers to the amount of time it takes for an algorithm to execute, while space complexity refers to the amount of memory it requires. Complexity analysis helps to identify algorithms that are efficient and scalable, and can help to optimize performance in large-scale applications. Data structures and algorithms are fundamental to many aspects of computer science and software development, including database management, artificial intelligence, and web development. Understanding these concepts is essential for building efficient and effective software systems. Debugging and error handling are critical aspects of software development. Debugging is the process of identifying and fixing issues in software, while error handling refers to the techniques used to manage and recover from errors in software. Here are some common techniques used for debugging and error handling. 1. Logging. Logging is the process of recording events and messages that occur during the execution of the software. Logging can help identify issues and provide useful information. For debugging. Unit testing. Unit testing involves writing automated tests to verify that individual components of the software work as expected. This can help identify issues early in the development process. 3. Breakpoints. Breakpoints allow developers to pause the execution of the software at specific points in the code to inspect the state of the application and identify issues. For exception handling. Exception handling is the process of catching and handling errors that occur during the execution of the software. This can help prevent the software from crashing and provide useful information for debugging. 5. Debugging tools. There are a variety of debugging tools available to developers, such as debuggers and profilers, which can help identify issues in the software. 6. Peer reviews. Peer reviews involve having other developers review the code and provide feedback. This can help identify issues and improve the quality of the code. It is important to have a solid understanding of these techniques and to use them consistently throughout the development process to ensure that software is robust and reliable. Thank you for watching us. Stay tuned for next part.